Okay, the midterm is tomorrow. The times are the same that they were for the first midterm. The exam will be ready to download at noon. Professor Fox is holding office hours today. He's finalizing the time, but just as mine over the weekend and yesterday were open to everyone, his will be open to everyone as well. You will know by the end of today what the sort of basic time frame is of the structured part of class today and the part of class that's open for questions. So all three of my sections today will be the same, and you're welcome to come for the last part of any of them. So to the extent you want to do office hours with me, it basically means coming to the last part of the sections because I've got class until 7:30 tonight. And Professor Fox is going to hold office hours this evening as well. So that is the setup. Everyone who had filled out the midterm 1 makeup request and said they needed the same makeup for all three exams, you were on the list. The people who didn't request them, I sent an email to. There were 2 people I have not heard back from. So if you are one of them, you absolutely need to get back to me by noon today. And when you download your exam, before you download it, look at it. The name of the exam says the time. And if you look at it and say, that's not what I expected, send me an email. So that's the drill on the exam. What we are going to do today is to start off by pushing some more on the things that we were doing with loans. So if you remember, I realize this was before yesterday, but what we're going to do is start off by reviewing the process we went through towards the end of class on Thursday, looking at how an amortizing loan works. So what I'm going to do is I'm going to take us back to the class 5 slides for a moment, and then I'm going to have you all work as a group for in small groups for about 5 minutes. So we're going to stop this share, pull up the class 5 slides, and then I'll show you what you're going to do. So many of you have ended up going through this in different ways in a lot of detail over the weekend. But what I want to do is bring us back to looking at what is actually happening with a loan. So again, there are 2 things. Every payment you make in an amortizing loan, part of that payment is paying interest on the loan. So interest is what you pay for the use of the money. When you borrow money, you're paying whoever you borrowed it from for the fact that you're using their money. It's sort of like paying rent on an apartment. So when you have a loan, and this was at the end of class, we calculated the payment on a $30,000 loan that was a 5-year loan and had a 6.75% APR. And the payment we got was $590.50. So that's the payment that we calculated. So what happens is that when we divided the interest rate by 12, so we divided 6.75 by 12, and the monthly interest rate was 0.5625. So what you owe in interest is 0.5625% times whatever you owe at the beginning of the month. So when we first start the loan, you owe $30,000. That's the amount of the loan. So when we calculate 0.5625% times $30,000, we come up with $168.75. That's the amount of interest that you're going to pay on the loan. but you've paid $590. So that means that some of your $590 is actually going to go to repay the loan. The amount you owe is going to be reduced because you're repaying it. So what happens here is that if you subtract the 168.75 from 590, you get 421. That amount of money is repaying the loan, and the loan is now going to be $422 less than it was at the beginning of the month. So at the end of the second month, you start off owing $29,578. And you're going to pay interest at 0.5625% on this amount, on the amount that you owe at the beginning of that month. So the interest is a little bit less because you owed a little bit less. So whatever's left over goes to repay the loan. And this process is going to continue for the whole 60 months of the loan. So what we're going to have you do is actually go through the process of doing this. And what we've created, I'm going to pull this up for you to look at. And this is posted on Questrom Tools for you to open up, but I'm going to show it to you and then I'm going to have you all work on it. So what we've put in Questrom Tools, you're going to pull this up and work on it. This is a 5-month loan. So what's going to happen when you do exactly the process that we were just doing on that slide, because it's 5 months, by the time you get through the whole process and come down to the end of month 5, you're going to owe $0. So the process of doing this, the first thing you're going to do is you're going to calculate the monthly payment. So let's have everyone actually calculate the monthly payment right now. I don't want you to you'll waste your time in your breakout rooms if you don't have the right payment. So go ahead and calculate that and put it in the chat box. So I'm getting some private and some not. So you're looking for the entire payment, not just the interest. So this is a 5-month loan. So N is 5. The present value is 2,000. The interest is 6 divided by 12, which equals 0.5, and solve for payment. All right, there you go. 40602. And let's work our way across. So what's going to happen is 40602, you pay the exact same amount every single payment. I'm going to do the first line with you, and then you're going to go into your breakout room. So let me just make sure that this is visible where you can pull it up. So you're going to the resources folder, you're going to worksheets, and I don't have it visible yet, so hold on a moment. Okay, where you're going is Class 6 materials. Let me screen share that with you so you see what I'm talking about. I put everything for today in a folder so you could get to it easily. So where you're going to go today is go to Class 6 materials, come down here and open this thing that says amortizing loan worksheet. And then the other thing you're going to use today is this PDF file down here. So open that. I'll bring us back to this. We're going to do the first line together. So calculate the interest for the first month and put it in the chat box. We're going to have lots of decimal challenges. So the interest rate, 0.5% interest equals 0.005. So multiply 0.005. There you all go. $10. So if we pay $406.02 altogether and $10 of it is interest, how much is left to repay the loan? Good. Claudia, you got ahead of me, but that was the right next number. So if we start this month at 2,000 and we repay $396.02, how much is left at the end of the month? Exactly. All right. So I'm going to give you, this has been designed to get you all the way. We made it a 5-month loan because we didn't want it to take too long to do, but we wanted it to be 0 at the end so that you would see how the whole thing works. So my experience when we do this in a classroom is that people do it at a lot of different paces. So I'm going to give you 5 minutes in breakout rooms to get this done. Some of you are going to figure it out really quickly. Some of you, it's going to be a little bit slower. That's totally okay. Think about your goal in the breakout room to figure out how to make sure you're at 0 by the end and to make sure that everybody understands what's going on. So those are your 2 charges. Everyone needs to understand what's going on and you need to get to 0 by the end. Recorder, and I'm going to pull up a Excel spreadsheet that has the answers in it. So first of all, take a look at it and see if this matches your numbers. So any questions on where the numbers came from? Nobody looks overly upset. All right. So what we're going to talk about for a moment is, you know, a 5-month loan, it probably didn't take you the whole 5 minutes, but it might have. That's kind of time consuming. But the other thing you can do that's a far more understanding what's happening in the loan and realizing that what you're doing when you have an amortizing loan is that every month you're paying the bank a mixture of principal and interest. But if you want to know how much you owe at any given point, what you owe at any given point is going to be the present value of the remaining payments. So if we came up here and said, what do we owe at the end of the third period? At the end of the third period, we have 2 payments left. So the other thing that we could do, so here's the end of the third period, $805.99. But at the end of the third period, we have 2 payments left. So the other thing we could do is say n equals 2, payment equals 406.02, I equals 0.5, and solve for the present value of that. So go ahead and do that just so you show yourself it's working. When you hit present value, you should get 805.99. So there are 3 things that you need to be able to do for this exam. And again, many of you have been working through all the practice problems and you're getting pretty good at this. So I'm just going to go over these and make sure everybody's clear what you need to be able to do. One thing you need to be able to do is say, what do you owe? So what do you owe at any point in time? And we're going to practice this stuff today. So what you owe at any point in time is the present value of what's left. That's one question. A second question is, what have you repaid? So let's look at that. We started at 2,000. At the end of the third period, we now owe 805.99. So tell me how much you've repaid in the first 3 periods. Put that in the chat box. Yes. So you've repaid. We'll use this as our example for everything. We owe 805.99. We've repaid 1194.01. And if we had wanted to do it more slowly, if we'd added up those 3 numbers, the sum of those 3 numbers would be 1194.01. But that's the slow way to do it. The faster way to do it is just to say, what do I owe? This is what I've repaid. The last thing you need to be able to do is to know how much interest you owe and how much interest you owe you've been doing. You calculated, so let's look at this, well, we'll do the one we've been doing. So in period 4, we start off with our 805.99, and the interest you owe is 0.5% on the 805.99. So those are the three things that when you look at all the problems, they're going to be a variation on things like that. So what I'm going to do now is I'm going to pull up the slide deck that we're going to use, give you an idea of where we're headed, and then we're basically going to do problems. The ones that we've picked out to start with are kind of a profile of things we want to make sure that we talk through and reinforce the underlying concepts. And then after that, we'll take a 15-minute break, and then it's completely open to anything anybody wants to work on. And if you don't want to work on anything at that point, it's okay to leave. So what I'm going to do here is give you a quick look at the big picture of where we're headed, and then we're going to head there. So what you're going to find, the other document that I told you about that I showed you in Questrom Tools, is I created a PDF file that has all of these problems without the answers. So instead of having to take pictures when you go into your breakout rooms, you can just take that file and you'll have it with you. So if you look at the red here, we're going to do another loan repayment thing, and I'll keep you all with me while we do that, because that's reinforcing what we just did in the with the amortizing worksheet. Then we're going to do a drill, making sure you know how to do the periodic rates. A lot of what happens in this exam is that we do problems, instead of being years, they're periods, so that you're practicing your periodic rates. So the faster you are doing those periodic rates, the better off you're going to be. And then the others are just a mix. We're going to look at loan payments. We're going to look at growing annuities. We're going to look at how much is left on a loan, simple interest, first payment in a growing perpetuity. I think I've answered that question probably 30 times in the past 48 hours, and calculating the interest rate on a loan. So that's going to let you practice things. And after that, you all can pick anything you want. So what I'm going to do is start us with this one right here. So hold on a moment while I get it set up without showing you the answers. Okay, so what I'm going to have you do is take 2 minutes, pick 3 minutes. This is like more than one problem, and it would absolutely, so when we tell you that there's 20 problems and you have an hour, that basically means you have an average of 3 minutes a problem. This would be more than one problem. So I'm going to give you 3 minutes to work on this. As you get the answers, put them in the chat box, and then we're going to go through it as a group. And while I do that, I'm going to pause the recording for 2 minutes so we don't recorder. So I'm going to put the numbers up and then talk them through. It's not letting me. Give me a second. It is not. There we go. So what we've just done here is to convert. So some of these answers are looking right, and some of them aren't. So everybody check what you've got against these numbers. All right, so I'm going to walk through with you how to do it. I'm looking at a range of different variations on what people did. And I think the best thing to do here is make sure everyone knows how you're supposed to do it. And then think as I'm doing it about any questions you've got. Okay, so let's make sure that everyone understands how to do this before we move on to the next slide. So the monthly payment is that one looks like people pretty much got from what I'm seeing in the chat box. So the monthly payment is the standard calculation. So we take the present value of our loan is 15,000. N is 72, 6 times 12. I is 6 divided by 12 equals 0.5. And you solve for payment. Now, if you go back to the worksheet that you just did, if you think about the top of that worksheet, what's going to happen? Let's pretend we're in the first line, because what we're talking about is the first month. So what we owe at the beginning is 15,000. Our payment is 248.59. The interest is going to be, so first month interest, we owe 15,000 at the beginning. We're paying 0.005 interest. Multiply those together, you get 75. So the interest in the first month is 75. There's that number. When you subtract the 75 from the 248.59, you have 173.59 remaining available to pay back the loan. When we come down to this one, what we're doing is we're saying, what's the present value of the remaining payments? So we're going to solve for present value. At the end of the second year, there are 4 years left. So you're going to solve for present value when n equals 48. And then the amount that you've repaid, if you started with 15,000 and you now owe 10,585.18, what's left is 4418.82.
Professor?
10,000, Angelina, that's fine. Yes.
So did you use 48 as n because there's 4 years left?
Correct.
Okay.
So it's the present value of the remaining payments. So if there's 4 years left, you still have to make 4 years of payments. So there's 48 payments left.
See.
Professor Newell, quick question. So if n was 24, shouldn't that value be equal to the amount repaid during the first 2 years?
No, because if n's 24, that's how much you owe in the last 2 years.
Okay.
Professor?
Yes.
Is there ever going to be a time where we only find out the amount that we ever paid during the first years? Because I feel like to solve that, we always like found out what we owe and then we always subtract it from the original value. But is there ever going to be a time where we only find out how much we repaid so far?
Sometimes the question might be how much have you repaid, but in order to answer it, you would need to say how much do you owe.
Okay.
You can't answer it without knowing how much you owe at the end. So I'm looking at a couple of the questions that are rounding errors I think they're probably okay. I would need to go through what you could do if you want to send your actual inputs to Sarah. But let me show you how to do this so that you don't have to worry about rounding errors, okay? So what we're going to do is look at these look at the two problems at the end there. So what I'm literally going to do is just go through the inputs with you. So what we're going to do is we're going to pretend that this was a problem, that the problem was what do you owe at the end of the second year, or that the problem was how much have you paid. And we're going to walk through doing it, making sure you get the exact number. So anytime you have a question like that, the first thing you have to do is go back to the beginning and find out what the payment is. So we're going to do that. 15,000 is the present value. 6 divided by 12. So say 6 divided by 12 equals, and then hit the interest button. So obviously you can do 0.5 in your head, but things that are a little bit different than that, it's a little bit harder. It's a 6-year loan. So N is 72, and then hit payment and leave it in your calculator. Don't change anything. So if we want to know what we owe at the end of the second year, the only thing that changes is how many payments are left. So just put 48 in for N and hit present value again. And now you've got this number in your screen. Plus it was a lot faster to get there because you weren't writing stuff down. So then to find out what we have to repay, what we've repaid, we just need to subtract that number from 15,000. So change it to, hit plus minus to change it to a negative, add 15,000 and hit equals. And then you have the other number and you won't have any rounding issues. All right. So everyone who got 04, it's just that you put the action, you put the payment in rounded to the pennies, and that's fine. It would have been fine on the exam, but this way you don't have to worry about whether I figure out that it's fine. All right. So I'm going to have you do this slide. This one isn't worth going into breakout rooms for. So why don't you take 3 minutes to get all these numbers, and then the next few problems we'll do in breakout rooms. So from the numbers that I am seeing, in the chat box, everyone's good with this. If you're not good with this, ask. Key thing here. Here is where I'll write this down. The instructions about number of digits really matters with this stuff. Because if you do EAR and APR conversions wrong, the wrong way of doing it can be about 0.1% difference. So if, for example, let's pretend that 10.54% was wrong, then if you only tell us 10.5%, we can't give you credit for it. Yes, 10.47 rounds to 10.5, but 10.54 rounds to 10.5 as well. So when we give you the instructions on the exam that say, usually for these, it says 3 digits after the decimal. So it's really important to do that. The reason we're doing it is so that we can verify whether or not you did the problem correctly. We want to be able to give you credit for it if we possibly can, but we need to make sure that you're not giving us an answer that would round from the wrong answer. So that's where one of them, that's where these instructions are coming from. So why don't we just quickly do them, because it's good to practice how do you do this in your calculator. So I'll just walk you through all of them. So for the first one, the best way when you're going to go from an APR to an EAR is to start with it as a decimal so that you don't make a mistake converting in the middle. So 10% is 0.10. So what we're going to do is 0.10 divided by 12. Now we have a monthly periodic rate. We're going to add 1 to that. We're going to take it to the 12th power. And when you take it to the 12th power, what you're going to see is 1.1047. Subtract the 1, 0.1047. And when you express that as a percent, it's going to be 10.47%. It's also really important that you express it as a percent if we say percent. Again, the reason for that is that if we told you that we wanted 3 digits after the decimal, the answer would be 10.471. That would be 3 digits after the decimal. If you give it to us as a decimal instead of a percent, you're going to say 0.10, and you're going to say, oh, that's 3 digits. But we can't give you credit for that because we don't know exactly what you got. So again, the reasons for being picky are to make sure we have enough information to know if you got the problem right. All right. So this is relatively quick. 0.5 times 12 equals 6%. This is relatively quick. 1.0015 to the 52nd power, and then take off the 1. You get back to 8.1%. And then we'll do the other one together. So we're going to, this is weekly. We're going to need to get a weekly rate. And then we're going to multiply it by 52 to get to APR. So to get the weekly rate, we're going to say 1.14. We're going to take it to the 1 over 52nd power. So the way we're going to do that is 1.14, orange, y to the x, 52, orange reciprocal equals, and that's going to give you well, we'll just make that a 3. Then we're going to subtract the 1, multiply that by 52, and convert it to a percent. Everybody good with that? All right. The next two problems in the slide deck are hard enough that I'm going to have you do each of them separately. I have no idea why I can't get my mouse to work while this is in screen share. So what I'm going to have you do here is I'm going to show you the document you're going to open up. All right, when you open up that PDF file on Questrom Tools, this is what you're going to see. So it's all these problems blank. And what I'm going to do is I'm going to have you take 3 minutes as a group in the breakout rooms to do the one that says loan payments. It's hard, okay? So talk it through, think about it, think about how to make it work. Then we're going to come back. So those of you who have been working on the practice problems, you know that there's a range of different problems that kind of use this structure. One of the things that's really important to do as you're studying is identify things that are the same problem that are expressed differently, because then you're going to understand better what the structure is. So what the structure of this problem is that if you're going to buy something, you save some money, you borrow some money, and the combination of these two amounts adds up to what you have available to pay. So in this particular problem, we've saved $500. The scooter cost $1,800. So that tells us that our loan is $1,300. So once you know that, you can figure the rest of it out. So present value is 1,300. N is 36. I is 4 divided by 12. And you solve for payment. Oops, didn't mean to do that. So any questions on that one? There's your payment. All right. So basically, to give you sort of a sense of what we'll do, I'll give you 3 minutes in breakout rooms to do this one. Then I'll have you do the next two so that you're not going in and out too much. And then we'll separate the other one. So when you do this one, the critical thing to do is to think about what the timeline looks like. So some of you probably got this figured out. Some of you are still trying to figure out how to do it. So if you're one of the people that knows how to do it, take advantage of the fact that explaining it to the other people is going to make you understand it much better. So 3 minutes to work on this one. There are two different ways to do this problem. One of them is to say, we're going to do a timeline. We're going to say that our first payment of $2,100 is today. We have 25 payments all together. So the last payment's going to happen at year 24. It's a growing annuity. So you need to use the growing annuity formula. In general, because that takes longer to do than problems that you can do quickly in the other keys on your calculator, what tends to happen on the exams is there'll be one problem where you need to do this. So if you decide that the way you're going to do the problem is to treat it as a 25 payment annuity that begins at time 0, so therefore we're going to get a present value at time -1. When you put that into your calculator, you're getting a value at time -1. So you're going to have to multiply it by 1 plus r to get to a value at time 0. So we'll do that together. But if you multiply it by 1 plus r, what you're doing is multiplying it by 1.07. So if you multiplied your answer by 1.07 and got the right answer, then what you forgot to do is you forgot you had a value at time -1, one period before the first payment, and that was the only mistake you made. So we'll do this together. What this is going to be is 1.05 divided by 1.07. Take that to the 25th power. Turn it into a negative, add 1. Multiply that by 1 over 0.02. So divide it by 0.02. And multiply that by 2,100. And you're going to get 39,487. Multiply that by 1.07 because 39,487, let's put this on our timeline. 39,487 is back here. And we have to multiply it by 1.07 to bring it forward to time 0. The other way to do this problem, which is totally fine, it's correct. And if any of you multiplied by 1 plus the growth rate and got this answer, you did it this way. And I'll show you what happened. So the other thing you could do is say, I have 2,100 today. What I'm going to do is find the present value of the 24 payments between time 1 and time 24. And then I'll just add the 2,100 at the end. That's totally fine. So what that would look like, I'm going to just put C for a moment, times 1 over 0.07 minus 0.05 times 1 minus 1.05 divided by 1.07 to the 24th power. and then we're going to add the 2,100. Now, the thing you have to think about if you're going to do this is that this payment right here is the second payment. It's 5% bigger than 2,100. So it's 2,205. So if you do it this way, your formula has to be 2,205 times all that. And then add the 2,100 and you'll be fine. Either way is totally fine.
Professor?
Yeah.
I have a quick question about the first way you did this problem.
Yeah.
So why is it 24 for n instead of 25? Or was it 25 that we used?
The first one we did, it was 25.
Right. So why was it 20? Why was it not 24?
Because the first problem, we did the value of all 25 payments.
Mm-hmm.
You have 25 payments altogether.
Right, but doesn't the question establish that we did the first payment, like 2,100?
You will receive. You haven't gotten it yet.
Okay, so we have to include that as well.
Yep.
Okay, thank you.
Yep. You're good at knowing what to read for. Okay, I think I'm going to give you a break from breakout rooms. They work really well, but going in and out of them too much probably gets a little bit tedious. So this is basically saying, okay, we took a break, we did some other stuff. This is going back and doing that first problem again that we did after we did the spreadsheet. So I will give you. So as you're checking your answers, your payment that you're working with is 22939. So take a moment. If you didn't have 22939 as your payment, take a moment to rethink it, and then I'll walk through it with you. So where you got the payment from, we go all the way back to the beginning. The present value is 10,000. N is 48. I is 4.8 divided by 12. Solve for the payment. And now the amount that you owe, all you have to do is change N to 30. If you originally had 48 payments and you now, that was 18 months ago, you've made 18 payments, you have 30 left, change N to 30, and the present value of those remaining payments is 6,472. And then to find out what you've repaid, just subtract that from 10,000. Questions on that? We've been doing that a lot today. You're probably getting pretty good at that. Okay. So the next one is actually a quick problem. It doesn't take a long time to do it, but you have to think about what the question is. So give yourselves a minute to think about it and then put an answer in the chat. In our review sessions is to make sure people really understand what simple interest is. What does it mean that we're not compounding? So when you multiply something by 1 plus r, what you're doing is you're applying the interest to, when you multiply it by 1 plus r to the power of the number of periods, you're earning interest on interest. And when you use the formula, when you use the keys in your calculator is programmed to assume that it's compounding. If you're getting simple interest, you're only earning interest on the $1,000. So what that means is that we start with 1,000. We earn 3% of $1,000 in year one, which is $30. We earn 3% of $1,000 in year two, which is $30, and you end up with 1060. So the critical thing here is when you see a problem that says no compounding, you're not saying 1 plus r times 1 plus r times 1 plus r. You're just multiplying the interest rate times the original deposit.
Professor?
Yeah.
So in this case, do we just completely disregard with when it says the bank pays interest monthly? Like, because
They are going to pay interest monthly. Because they're not paying interest on interest, you're going to multiply it. But you could say 1,000 plus, give me 1 second. So month one, we're going to get $2.50. Month two, we're going to get $2.50. Month three, we're going to get $2.50. All the way out to month four. Month 24, we're going to get $2.50. And 24 times $2.50 equals 60. So 1,000 plus 60 equals 1,060.
got it.
It's just that the math is easier because you're not compounding, so you're just multiplying.
Professor?
Yep.
Can we just use the future value key to calculate for the?
No, because your future value key is programmed to compound the interest, and there's no compounding.
Oh, okay.
Right.
Thank
See,
you.
that's what the calculator is programmed to compound. It's just the way that's what you paid for, is for it to do the compounding for you. But if you don't want it to be compounded, then you don't want that.
All right.
Okay. So this is a hard problem. The last two are definitely hard problems. So what I'm going to do is I'm going to give you I'm actually not going to put you in the breakout rooms because you might just drive each other crazy. I'm going to give you 3 minutes to figure it out, and then I'll explain it. But see if you can figure out how to do it. Anybody else want to take a guess before I work it through with you? All right. So what we've got here, there's the answer, is the first payment is going to be at year 3. In order to figure out the first payment, we need to somehow look at this problem and come up with a way of looking at it that the payment is the only variable. So when you look at it, you might sort of start down the road of saying, oh, well, if I knew how much I had at time 2, the value at time 2, and a lot of times doing these problems by using a subscript for the time will help you keep track. So the value at time 2 is going to be the payment at time 3 divided by R minus G. Well, we have growth and we have the rate. So we know that that denominator is 0.02. But we don't know what the value is at time 2. So we've got 2 unknowns there. But what we can do is, if we're investing $1 million today, and we're not taking anything out until that third payment, we can find out what the $1 million grows to by time 2. So you can let 1 million be your present value, N is 2, R is 6, solve for future value at time 2. And you're going to get 1,123,600. And then just now what we're going to do is we're going to solve for, clean this up for you. $1,123,600 equals payment 3 over 0.02. Multiply both sides by 0.02. And payment 3 equals 22,472. And again, that's a hard question. What has tended to happen over time is that it's on the practice exams. There are definitely things that over time people really learn how to do because they're in the practice exam. So I would say that a reasonable number of people end up getting this correct on the exam just because we're teaching you how to do the problem. All right, one more problem in this slide deck. We left the last 2 are kind of hard problems. So we leave them for the end. So again, let's take 3 minutes to play with this one. And then we'll do it together. So basically, picture what you're doing here is you're setting it up to say the net of what we're getting at time 0 is 1,200. So put in 1,200 as your present value. Then you're going to make 7 payments of 200. Solve for the interest. When you solve for the interest, you're getting a monthly interest rate. So you have to multiply that by 12. And you get 48.1% as your APR. So that is the end of our pre-designed set of problems. So what we do is we intentionally create a cross-section of problems that have us go through class today, reviewing all of the different skills and tools that you need to do the exam. So if you go through the practice exam, what you're going to do is you're going to see a lot of places where you say, oh, that's like the problem on the 4th slide. This is like the problem on the 6th slide. So try to use the things you've learned to do the problems in the practice exams. So it's 10:15. I'm going to tell everybody to take a 5-minute break, just so you sort of, I don't want you to sort of say, okay, help me with this problem and realize that it's exactly the problem we just finished doing. I want you to get the value of kind of thinking for a minute. If you're all set, you don't need to stay. At this point, you can be done. You just got an email from Professor Fox. He is doing office hours at 8 o'clock tonight. So great opportunity. When you get on Questrom Tools, in the overview, you will see the Zoom ID for his office hours. He and I use different Zoom IDs because sometimes we have them at the same time. So take advantage of his office hours, and everybody take a 5-minute break. Feel free to leave if you want to. And then in 5 minutes, we'll spend the rest of the class just answering any questions people have. So it'll be your time, okay? Turn the recorder back on. All right. So what's going on with this problem is that you've borrowed $2,000, you're paying 6% interest, and the critical thing here is you are not repaying any principal until 5 years from today. So this is not an amortizing loan. This is a loan where the only thing you're paying every month is interest until you get to the very, very end of the loan. So what's going to happen here is that every single month, come back here, every single month, you're going to owe, we owe $2,000 until the very, very last day. So each month you owe $2,000, and you're going to pay 0.06 divided by 12 on that 2,000. So each month you owe $10 of interest per month. And the question is, how much are you paying in the 4th year? So since all you're paying in the 4th year is interest, and you're paying $10 a month, then in an entire year, you're going to pay 10 times 12 months, and it'll be $120. So 33, it's the same thing that we did in the slide deck during class. You're paying interest with no compounding. So however much you have at the beginning, whatever your original deposit is, every month you're going to pay 0.04 divided by 12 times the deposit. That's going to be every month. We have 36 months. So the total interest is going to be 36 times 0.04 divided by 12. Which equals a total of 0.12 times the original deposit. So now it's basically algebra. If 1680 equals 0.12 times the deposit, plus the original deposit. So you have what you have in your account is the deposit plus 12% of the deposit. So 1680 equals 1.12 times the deposit. Divide both sides by 1.12. And the deposit equals 1,500.
Wait, Professor? Yeah. I don't understand. One thing I don't understand is you said deposit minus 0.04 over 12 times.
Oh, the deposit. That's an arrow.
Oh, okay. 0.04.
So you're going to put the deposit in.
Mm-hmm.
then you're going to have, so at the very end, what you're going to have is the deposit plus all the interest that you've earned on the deposit. The
Right.
interest is 0.04 divided by 12 a month.
Mhm.
We have 36 months altogether, so the interest is 0.12 times the deposit. You also still have the deposit, so you've got 1.12 times the deposit, and then it's just algebra.
Okay, so that 0.12, right? Out of 1680, that accounts for all the interest that's been accumulating, right, for the past
Right.
years. Okay, and is that 1.2 towards the left? 1680 equals 0.12. Is that supposed to be 1.12?
So do it in your calculator.
Okay.
0.04 divided by 12 times 36.
0.12.
Exactly. You don't learn this stuff if you don't do it along with me. You can probably learn poetry listening to it, but math you got to just kind of do. All right, so number 34. Again, this is a variation on the one we did in the slide deck. So I'll do the same little diagram that I did. You save dollars, you borrow dollars, and then you buy something. So the amount that you save plus the amount that you borrow equals what you have available to buy it with. So in this, and different, there's 3 different things there, and different problems will give you different things, but that's the basic structure of the problem. So you've saved 5,000. What we've done is we've given you the information to figure out what you can borrow. And the question is, how much do you have available to pay for this jet ski? So to figure out how much we can borrow, N is going to be 60. I is going to be 6 divided by 12. Sorry, no. 3 months. N is going to be 4 times 5 equals 20, because it's a quarterly loan. I is going to be 6 divided by 4. Payment is going to be 1,500. Put all that in and solve for present value. Present value is 25,753. So if we've saved 5,000 and we're going to borrow 25,753, we have 30,753 available to buy the jet ski.
So, Professor, would this equation be useful for questions that have some sort of down payment? Like this diagram?
That's exactly what this is. This is a down payment.
Okay.
So it's what I'm getting you to do is think about what's the big picture here. You want to buy something. You've saved some money, but you haven't saved enough money to buy it. So you're going to need to borrow some money. And the combination of the amount that you can borrow and what you've saved is what you're going to use to pay for it. So in this particular problem, the question is, what can you pay for it? You know how much you've saved, so you have to calculate what you can borrow based on how much you can pay each month. So the next one you guys put up was 35. 35 and 36 together, so we'll do these two together. They're a pair. So what we've got here is it's going to happen forever. So you've got a perpetuity. It's going to grow at 3%. So it's a growing perpetuity. We're not going to fund the first home until 4 years from today. And we know how much we're investing today. So this is the same problem that we did, the second to last problem that we did in the slide deck. So what we've got is we have a timeline. The question is, what is this payment going to be at year 4? We have G and we have R. So the value at year 3 is going to equal the payment at year 4 divided by 0.05 minus 0.03. In order to figure out what we have at year 3, we're going to start with the 10 million that we invested today and find out what it has grown to by year 3. So you can put this in as your present value. I is 5, N is 3. Solve for future value. And your value at year 3 is going to be 11,576,250. That equals your payment at year 4 divided by 0.02. Multiply both sides by 0.2 and you get 231,325. So to think about 36, which I think is also on your list, if you're going to increase at 2% instead of 3%, what that means is that your value, so value is C over R minus G. If we change G from 3% to 2%, if you have a smaller G, the denominator just went up. When denominators go up, present value goes down. So it's going to decrease. You can also kind of think about it intuitively. If it's not going to grow as fast, you don't need as much money, so you don't have to invest as much. So the other two questions out there are 11 and 24. We'll probably have time for more. So this is actually the same as the one we just did. In this case, once you solve for that payment, once you solve for the payment, it's actually asking you the third payment. So you're going to have to increase it by 4% for 2 years to find it. But the method of finding the first payment is the same. And then we can increase it 4% twice in order to find the third payment. So the way we're going to do it is the first payment is in 3 years. So we need to find payment 3, and then we can find payment 4 and payment 5. The value at year 2 is going to be whatever payment 3 is over, we have R and we have G, over 0.06 minus 0.04. We know that we're investing $44,500 today. So in order to find the value at year 2, we'll make this our present value. N is 2, I is 6. Solve for future value is 50,000. So 50,000 equals payment 3 divided by 0.02. So payment 3 equals $1,000. So that's 1,000. Payment 4 is 4% higher. So it's 1,040. And payment 5 is 4% higher than that. So it's 1,082. Actually, hold on a sec. I was going to see what 11 is, but you probably haven't finished writing that down. So hold on a moment. All right, number 11. So starting with a timeline, we're going to make 10 $5,000 deposits. So the first one will be at year 4. And the 10th one will be at year 13. And the question is, and this is your 10th reunion is at year 13. So the question is, how much money do you have at year 13? So for purposes of a timeline, we don't really care what's happening here. We have our first one and our 10th one, and what we want to know is the future value. So N equals 10, I equals 6, payment equals 5,000, and you solve for future value. All right, that's the list that you all had in the chat box. Are there others?
Professor Newell?
Yeah.
Could we go over number 14?
Yep.
Thank you.
So in 1 week, your return, you got 1.02, you started with 1.00. So you got a 1.02% increase in a week. And the question is, so an EAR is going to be taking that weekly return and taking it to the 52nd power. So your EAR is going to equal 1.02 to the 52nd power minus 1. So 2.80 minus 1 equals 1.80, and 1.80 is 180%.
While you're on the question, like,
Yeah.
because when I read this question, I read it as like a 2% increase because it increased by 2 cents, right?
Yeah.
So by increasing by 2 cents or like 2%, is that the same as expressing as increasing by 1.02%?
It increased by 0.02%. So the increase was 2%,
Right.
which equals 0.02. So the EAR equals 1 plus 0.02 to the 52nd power minus 1.
Got it. Thank
And
you.
1 plus 0.02 is the same as 1.02. Eight, yes. So the key thing here is that you're looking for the remaining value of the annuity. So you only care about the payments left, starting with immediately before the fourth payment. So drawing ourselves a timeline of the payments that are left at that point, what we're going to get is, so we're starting immediately before, so we're going to include that payment. So the fourth payment, the 5th, the 6th, the 7th, and the 8th. That's the timeline we're looking at. And for purposes of analyzing it, if we are at the fourth payment, this is time 0, 1, 2, 3, and 4. So at that point, you can do it. You can either put in your payment is 500, N is 5, I is 2. You're going to get a present value of $2,357, and that is the present value at time minus 1 period before that first payment. So we have to multiply it by 1.02. And it's actually 2,404. I rounded it wrong when I posted this. The other thing you could do, which would be fine, is write down 22 and 20. Sarah, yes, we can do those. The other thing you could do is 500 plus the present value of the remaining four payments. Either one will get you the same answer. $22 and $20. Make some spaces here. If it says immediately after, you change exactly, that's the right answer. You just don't include that 500. So for number 20, this is the problem that we did right after we did that spreadsheet when we said, how do you figure out what you still owe on a loan? So the original loan was $1,200. And it was a 5-year loan. We're going to repay it today. So we need to know the present value with 36 payments left. But in order to do that, we need to know the payment. So the first thing we're going to do is find the payment. So present value is $1,200. N is 60. I is 3.7 divided by 12. Solve for the payment. Which is 21.94. And then change N to 36 because we have 36 payments left. Solve for the present value of that. And you'll get 746.42. And for 22, what you're looking for is a future value of 10,000. You currently have 6,000. And because it's compounded monthly, we're going to need to set it up. You have to match it to your cash flows, your N, to the monthly compounding. So N is going to be 84, which is 7 times 12. And you're going to solve for I, and the I that you get is going to be a monthly rate. So we're going to have to multiply it by 12 to get the APR. So when you solve for I, you're going to get 0.60998. Multiply that by 12, and you get 7.32.
Professor?
Yeah.
I have a question about 20.
Yeah.
So for 20, it asks like how much we owe, like how much is left to repay, right?
Yep.
And we established that there's 36 months left to repay the loan, right?
Right.
But let's just say, for example, the question asked us how much we repaid already, right?
Yep.
Then because we went through, because since it's 2 years after we borrowed the money, is it valid for us to put 24 as the end?
and keep everything the same.
So what you've paid, you started off owing 1,200 and you now owe 746.42.
Right.
So you've repaid the difference between those two.
Okay. But I'm just saying, like, you know, in like for this question, right? If they didn't ask us first, like, how much we owe the bank, but instead, how much did we already repay? Instead of putting N for 36 for N, and we're trying to find how much we already paid, how is it okay for us to put 24? Because that's 2 years after I borrowed the money.
So if you do future value, yeah, you could do that.
Okay.
All right, we will do 18. That will be our last one. All right. So 18, you borrowed $20,000. It was a 5-year loan. You had monthly payments. And the question is, what do you owe today? That was 4 years ago. So you have 12 payments left. In order to do it, so you can look at it and say, I need to know the present value with 12 payments left, but we need an interest rate. So we need to go back to the beginning of the loan to get the interest rate. So present value was 20,000. It was a 5-year loan, so N was 60. The payment was 396.02, which will be negative, and we're going to solve for I. I is going to be 0.5833 per month. Now, again, once you have that information in there, you don't have to re-input it all. You've already got the key information to figure out what you owe today. You have the interest, you have the payment, and what you need to know is what's the present value with 12 months left. So change N to 12 and solve for present value. All right, everyone, you are ready for a break. So again, the structure